2.6, proving angles congruent. Our objective in this lesson is to prove and apply theorems. Yes, now we have theorems about angles. We are going to use given information, definitions, properties, postulates, and previously proven theorems. We don't have any of those yet, but we will soon, as reasons in a proof. And we are going to use deductive reasoning. Remember, that uses facts. Here is our vocabulary. A theorem is a conjecture or a statement that you prove true. And if you remember, postulates are accepted as fact. Theorems must be proven. So anytime we encounter a theorem, you're going to know that there is a proof that makes that theorem true. So let's take a look at our first theorem here. Your very first theorem, very exciting. This is a fan favorite. It is one that we are going to use frequently. The vertical angles theorem. We will use this and linear pair postulate together quite a bit. Vertical angles theorem says that vertical angles are congruent. This is something that you already know, but now we have a theorem to prove it. So we have our vertical angles here, and we know that these angles 2 and angle 4 are congruent because they are vertical angles. And we also know that angle 1 and angle 3 are congruent because they are also vertical angles. Vertical angles are created when two lines intersect. All right, so let's look at the vertical angles theorem. How do we prove that? Well, we are given here that angle 1 and angle 3 are vertical angles. Okay, that's just definition of vertical angles. Two angles that share the same endpoint and their opposite, or their sides are made by opposite rays, right? They're just the opposite angles that are created when lines intersect. We want to prove that those two angles are congruent. So let's look at our proof. We know that 1 and 3 are vertical angles. That's given. We always start our proof with vertical angles. Now let's do some ideal up here. We want to prove that that is congruent to that. Do we have anything that helps us do that? Well, let's take a look here. Do you see a linear pair? I see a linear pair right there. And do you see another linear pair? How am I going to draw these? Right here. And what do you notice about these two linear pairs? I see that they share angle 2. So we have the linear pair postulate, which says if two angles are a linear pair, then they are supplementary, right? And we also have a reflexive property of congruence, because we're dealing with congruence here, or possibly equality. Yeah, they're going to use equality down here. But the reflexive property for angle 2, notice I'm not writing out anything fancy. I'm just writing down, I'm marking my diagram and writing down anything that I might use, any of our definitions or postulates that I might use. And how do I make the blue angle? How do I make that blue angle? Measure of the blue angle is made by taking the measure of angle 1 plus the measure of angle 2. And how do I make the green angle? Well, the green angle is made by the measure of angle 3 plus the measure of angle 2. And what are both of those? Well, that's just our angle addition postulate. Right? I'm just adding those two angles together. So I've set up all of this, and with linear pair postulate, we know that that goes along with things being supplementary. So we might use our definition of supplementary. So let's take a look at how we put all this together. So angles 1 and angle 3 are vertical angles. That's given. And then I know that angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. And where does that come from? This is just our linear pair postulate. You can write it out if you want to. Angles that form a linear pair are supplementary, or you can just call it the linear pair postulate, because that's linear pair postulate. Now, the measure of angle 1 plus the measure of angle 2 equals 180 degrees, and the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Because we know the sum of the measures of supplementary angles is 180 degrees, this is just the definition of supplementary. Right? You can write it out if you want, or you can just write definition of supplementary. So now I have these here, and take a look at what we just wrote down. Look at that right there. I have two equations here that equal the same thing. And so I can cut out the middleman, right? A equals B and B equals C. And I can simply write, right, this right here is equal to this right here. And what lets me do that? That is our transitive property of equality. Now, if you called it substitution property, I could understand that. But these are two separate ideas that we are combining into one. So it's much more of a transitive property of equality. Now, what am I going to do with these? Well, I am going to take angle 2 here and subtract out the measure of angle 2, because that's just a number. Oh, you know what they didn't put in here? That's very bad form. They should have added that the measure of angle 2 equals the measure of angle 2. Should have put that in right there, or it could go after that anytime before step 4. And what lets us do that? The reflexive property of equality. Because if we're going to subtract it down here, if we're going to subtract the measure of angle 2 from both sides, we need to be able to say that the measure of angle 2 equals the measure of angle 2, so that we are subtracting the same thing from both sides. So to get to step 5, that's just the subtraction property of equality. And what are we left with when we cancel out angle 2? That the measure of angle 1 equals the measure of angle 3. And what do we know about angles with equal measure? Well, we know that they are congruent. Angles with the same measure, right, are congruent. You could just write this as definition of congruence. So we worked our way through. We did our ideal setup, and we worked our way through and figured out a way to get to them being congruent. I know these are a bit of a challenge. You'll get better at them. All right, let's look at a problem. How do we use the vertical angles theorem? You know this. You've done these already. We just now have a theorem that lets us prove it. We can see that we have vertical angles here. We automatically go in and mark them congruent. Congruent means equal. I write my equation, solve for x. You know how to do those. All right, let's look at a proof that uses the vertical angles theorem. We are told that angle 1 is congruent to angle 4. So I go over to my diagram and I mark angle 1 congruent to angle 4. And I want to prove that angle 2 is congruent to angle 3. Well, what can I do to do that? Let's erase what we have here so we can look at it. I have two lines intersecting. So I can take angle 1 and angle 3. I'm going to know that angle 1 is congruent to angle 3 because of my vertical angles theorem. Theorem is shortened to THM. That's fine. And I also know that angle 4 is congruent to angle 2 for the same reason. And now, because I have 1 and 3 are congruent, and 2 and 4 are congruent, and 1 and 4 are congruent from my given statement up here, I see some transitive property going on, right? Because if I can say 1 is congruent to 4 and 1 is congruent to 3, I'll be able to cut them out and be left with just, the remainder. So let's look at this. I write down my given. Angle 1 is congruent to angle 4. And then I put in angle 4 is congruent to angle 2. Because of my vertical angles theorem. And you can say vertical angles are congruent, or you can write vertical angles theorem. And then I also know angle 1 is congruent to angle 2, because look right here. That's transitive property of congruence. Because I can cut out angle 4 from both of those, and it's congruence. Now the next thing I'm going to do is say that angle 1 is congruent to angle 3, again, because of our vertical angles theorem. And then, if we look here, I've got those two that are the same, so I can use the transitive property of congruence again. And that was what I was trying to prove. All right. So I'm going to erase this so that we can look at problem 2. I normally make you pause the video and go through this, but I will help you with the proofs for a while. It says use the vertical angles theorem to prove the following. This time we are given angle 1 is congruent to angle 2, and we want to prove that everyone is congruent. So how are we going to do that? Well, let's take a look. We know 1 is congruent to 3, and we know 4 is congruent to 2, right? Vertical angles theorem again. And then, what can we say? If 1 is congruent to 3 and 1 is congruent to 2, we are going to be able to say that one's going to be congruent to 3, and no, we've got 1 and 3 are congruent, and 1 and 2 are congruent. So angle 2 is what we're missing here. Angle 2 is congruent to angle 3, right? And we know 2 and 4, so we can say angle 3 is congruent to angle 4, which is going to give us angle 2 is congruent to angle 4, which means angle 1 is congruent to angle 4, and everybody else, this is just a whole lot of transitive property of congruence. Yeah? And we'd write that up in a nice proof. Part B says, how can you prove the previous theorem without using the vertical angles theorem? So let's erase that and take a look at it. Do you see anything that might be helpful? I see that we have a linear pair there. Do you see that linear pair? I also see another linear pair here, and one down on the bottom and one on the other side. So we could use the linear pair postulate. If I know 1 and 2 are congruent, and then I have linear pairs, then I know 2 and 3 are congruent, or 2 and 3 are a linear pair, 1 and 2 are a linear pair, and they're going to share angle 2 here, right? So reflexive property of congruence this time, and probably angle addition postulate. That would mean it's reflexive property of equality. But we just did this problem, didn't we? Right? We just did this problem. That was the proof of the vertical angles theorem. We used angle addition and linear pairs to prove that those were congruent. So we would just prove that vertical angles are congruent to prove that the rest of them are congruent. Using the vertical angles theorem makes it a whole lot easier. All right, I am going to leave this proof up right here while we go down here and talk about paragraph proofs. If you like paragraph proofs, you are welcome to use them. I find the 2-column proofs a lot easier for novice proof writers. It's a lot easier to see what you've done and where you are going. A paragraph proof is just simply written as sentences in a paragraph. It's exactly what it sounds like. This is the same proof from up above. So let's look here. It says angle 1 is congruent to angle 4 is given. That's step 1. And then if we look, step 2 just says angle 4 is congruent to angle 2 because vertical angles are congruent. Or we could say the vertical angles theorem. And then if we look, what does step 3 say? We're using the transitive property of congruence. So there's step 3. By the transitive property of congruence, there's our statement. And then look at step 4. Step 4 is vertical angles theorem. These angles are congruent because the vertical angles are congruent. And lastly, step 5, we use the transitive property of congruence again to say that angle 2 and angle 3 are congruent. So you can see this is exactly the same proof. It's just written as a paragraph. And again, if you really like it, you can use it, but I'm going to recommend you stick to 2-column proofs because until you get really good at these, you need to be able to see what you're doing. All right, now we have a whole set of theorems here. The vertical angles theorem is a special case of this following theorem called the congruent supplements theorem. So what do you suppose the congruent supplements theorem is going to do for us? It's going to deal with supplementary angles, and the angles might be congruent. Right? I love math and science. They name things appropriately. This says, now look, we have an if-then statement here. So our requirement, if 2 angles are supplements. And what does supplements mean? Supplements mean that they sum to 180, right? If 2 angles are supplements of the same angle or of congruent angles, and that'll become more important as we go, because congruent angles are essentially the same angle. Does that make sense? Congruent angles have the same measure, they're just the same angle drawn somewhere else. So our requirement, if 2 angles are supplements of the same angle, then what's the result? Then those 2 angles are congruent. Well, let's take a look at this. It's not as hard as it sounds. Here's our requirement. Angle 1 and angle 3 are supplements, so I know that if I add these together, they sum up to 180. And I know that angle 2 and angle 3 are supplements. So if I take this and I add them up, it's going to equal 180 as well. Now what that tells me, my result, because angle 3 here, angle 3, is supplementary to angle 1, right? Look, 3 is the angle that repeats. 3 is supplementary to 1. 3 is also supplementary to angle 2. Angle 1 and angle 2 have to have the same measure, right? So let's look at this in numbers. If you're ever stuck and having difficulty, try throwing in some numbers. So if angle 3 measures 100 degrees, what do you know about angle 1? Well, angle 1 has to measure 80 degrees because we know they're supplementary. Now let's look at the second case. If angle 3 measures 100 degrees, what does angle 2 have to measure? Well, angle 2 has to measure 80 degrees because we know they are supplementary. And so if my angles, if the measure of angle 1 equals the measure of angle 2, then I know that angle 1 is congruent to angle 2. That's just definition of congruence. And if you look down here through our proof, that's exactly what we do. Because they're supplementary, that's given, we can say that they sum to 180. Right? Isn't that what we just did up there? They both sum to 180. How come? Definition of supplementary, right? By definition of supplementary. Okay. Then, if I have, look right there, that is my transitive property of equality. Lets me set these equal to each other. And then what do you see in there? Do you see the angle 3 on both sides? I'm just going to use the subtraction property of equality. And what am I going to be left with? I'm going to be left with the measure of angle 1 equals the measure of angle 2. And by definition of congruence, right? Angles with the same measure are congruent. That's just definition of congruence, that my angles are congruent. So let's look back at our theorem here. If two angles are supplements of the same angle, so the same angle is angle 3 here, and our supplements are angle 1 and 2. So the requirement is angle 1 is a supplement of angle 3 and angle 2 is a supplement of angle 3. Then my two angles are congruent. And it's pretty obvious once you look at it, okay, but it's actually a fairly useful theorem. So it's something you might want to remember. All right, the next three theorems are very similar to the congruent supplements theorem. We have the congruent complements theorem, which says exactly the same thing, but what is complements? Complements are 90 degrees, right? So if two angles are complements of the same angle or of congruent angles, because congruent angles are the same thing, so our requirement here is that they are complements, then the two angles are congruent. And this next one, we're going to put big stars next to this, and you should go in your big packet in Chapter 2 and find Theorem 2.4 and put lots of red stars next to it, because we are going to come back to this, and I am going to say you should know this, and you're going to forget it. And I'm going to reference you to chapter 2. This is a biggie. It has no name, but it's very short. This theorem says all right angles are congruent. So if we can show that something is a right angle and another angle is a right angle, right? We are told here our requirement is if we have two right angles. And how do we know that things are right angles? Well, we're either told they're right angles, they're marked right angles, or perpendicular gives us right angles. We're going to run into a lot of things that are perpendicular. I'll tell you that right now. All right angles are congruent. Tells me that angle 1 and angle 2 are congruent. And this is a theorem, so there is a proof for that. It's pretty easy proof. We have a right angle, that's given. And what do we know? That the measure of that angle is 90 degrees. That's pretty much the definition of right angle. And so if we have two right angles, right, we've got two right angles, I know the measure of both of those angles is 90 degrees. If my measures are equal, then by definition of congruence, my angles are congruent. Right? My measures are equal, so my angles are congruent. Very simple proof on this one. And the last one, we don't use it as much, but it's a good one. It's good stuff to know here. It says that if two angles are congruent, okay, so they're congruent and supplementary. So I've got two angles that are congruent and supplementary. Congruent means what? Congruent means we have the same measure, right? And they're supplementary. So I know that these two add up to equal 180 degrees. Can you tell me what those two angles measure? If they have the same measurement and they add up to 180 degrees, the result is that both of them are right angles. And that's really easy to prove. This is another very simple proof. I have two angles and they're congruent. And so in math, if I don't know the measure, I call it x. And if I label this one x, what do I know about angle 2? Well, it's also x because they're congruent, right? And congruent means equal measure. So I've got angle 1 and angle 2 are congruent. That's just given. Then I know that the measure of angle 1 equals the measure of angle 2. That's just definition of congruence. Okay? And then this is just math. I know that they're supplementary, right? I'm given that they're supplementary. So I can say x plus x equals 180, right? That's just going to be substitution. So I know that they're supplementary. I know that they equal 180. I can add them up to equal 180. That's just definition of supplementary. I should put definition in there. And then I can just substitute in. Oh, we might as well just write the whole proof here. The measure of angle 1 plus the measure of angle 2 equals 180. Definition of supplementary. Now I can just substitute in x plus x equals 180. 2x equals 180. Divide by 2. X equals 90. And that's just substitution property. Combining like terms, so distributive property. And division property of equality, right? That's x equals 90, is division property of equality. And so I can just come over here, and this is 90 degrees, and this is 90 degrees. And what do I know about angles that measure 90 degrees? They're right angles. That's just definition of right angles. All right, so a lot going on here. I truly believe that you will get this. Proofs are a little bit challenging. You are going to have your best friend at hand so that you can look up your postulates and theorems and definitions and use the ideal method to brainstorm. That's all ideal is. Your defined portion of ideal is brainstorming. We are putting together all of the postulates, theorems, and definitions that we can possibly use, and then we're going to sort them out to make a nice, pretty proof. You cannot just jump into a proof and actually manage to do it. That will just frustrate you and make you dislike proofs. So we will work through these. I believe in you. Enjoy the homework.